hope they catch you down.
All right, so the initial side is the side where the angle begins. Will, you are being recorded. Do you want to say hi to Jared?
Is he on? Jared's not going to watch that.
Hi, Jared.
What's up, Jared?
Hi, Hunter.
Hunter's not watching that either.
Yeah, they're both not watching it.
Terminal side,
I hope they catch it down.
the side that defines an angle. Also the ending. And radians. A unit of measure equal to 180 divided by pi, which is approximately 57 degrees. Oh, we do need calculators today.
No.
Oh, sorry. Just kidding. So typically, those of you that haven't taken pre-calc have never heard of radians before, probably.
I've heard of
You have? So in geometry, you did everything in degrees. Today we're going to do it with degrees and radians. The easiest way to do it is probably just to convert it to degrees, because most of you know how to graph degrees better than you do radians. But I'll show it both ways.
Isn't radians every single line?
Every single what?
Every single little line?
No.
No.
All right, Greek letters will be used to denote angles. Like X, we use algebra. Greek letters are used for angles. Alpha, beta, gamma, and theta. We're pretty much going to use theta all the time. And whenever you guys go to college, and some of you join Greek life, you will have to learn the whole alphabet.
What the hell is Greek like?
Some people. Yeah.
Many. I still haven't seen any with Target. Together?
Is that a Y or a V?
Together?
It is. All right, so the first one we'll just label in degrees. 0 degrees, 90 degrees, 180, and 270. And if you go one full circle, it would be how many?
360.
360.
You're way too excited.
Oh, we have the magnet on here. Yes,
We don't have to do the unit circle in this class, right?
we do.
Damn
We
it.
do the unit circle. However, you get to use a unit circle formula sheet on any exam.
What is that?
What do you mean
You'll learn.
unit circle?
Well, we could do damn
Way to memorize it.
Okay. Now, radians. Radians will start out 0. It's kind of hard to read, so pay attention. Pi over 2, or pi halves, is the same thing as 90, but this would be in radians. Pi halves is the top.
You're really triggering me right
Pi. Me? Too much writing at once?
now. No, just because of breakout.
Oh, 3 pi over 2. That'll be a lot easier than figure out. Relax.
We don't have to do.
Relax. Frankie says relax.
Considering I didn't take Greek calc for geometry last year.
You'll be fine.
I just don't want logarithms.
There are no logarithms.
Oh, good.
All right, so I drew an example of an angle that's in the first quadrant. So here's my initial side and my terminal side, and I drew an arrow to show that it was going up, because technically you could have a negative angle that goes down. Okay? So we have radians and we have degrees. All right, the next one, which my slide's a little bit off. Let's kind of fix this. I drew an obtuse angle, greater than 90 degrees, and I'm showing that theta is in quadrant 2. Do we remember our quadrants?
There's 1, 2, 3,
1 goes
4.
here, and then counterclockwise, 2, 3, and 4. Now, if theta's in quadrant 3, it could be like a super big angle that goes over 180 degrees, or it could be a negative obtuse angle that goes down. So I think I drew a negative one on here. So that would be like negative 120 degrees or something. And then the last one I showed in quadrant 4, again, I showed it with a negative, but it could be a positive, anything over 270. So we're not going to use a protractor when we're drawing these. We're just going to estimate them just like we did on the bell ringer. Just just have it approximately. Doesn't have to be perfect. First three are in degrees.
Is 4 1V?
What?
Is 4 like 1V? Roman numeral.
Yes.
Right. I do.
Drawing angles. Estimate approximately 60 degrees. So if you need to, you can label the reference angles. So 0, 90, 180, 270. So we know 60 is going to fall between 0 and 90. So we're going to have our initial side and our terminal side. And I would like if you draw an arrow pointing from the initial to the terminal so that I know whether it is this angle or this angle. Because technically it could be negative that goes around. Okay? 280. 0, 90, 180. It's a little messy. So here's 270. It needs to go past that point. So we'll start with our initial side on the x-axis. 280 will be just a hair past 270. And my arrow will be going counterclockwise. Now negatives, when you do your negative angles, you're going to want to label with negative reference angles. So instead of putting 90 at the top, you'll have 0 here. This will be negative 90. This will be negative 180 and negative 270. So initial sides always starts exactly where the x-axis would lie, and then it'll be a little past negative 100, or negative 90 to get negative 100. And we'll draw our arrow going downwards towards the terminal side. See if you guys can try the next 3. And I think we'll get 3.
Come on with the best.
Yours is not the best. Yours is
Good.
terrible.
Good, good. All right. On the back, we're going to see radians. Okay. We'll start out with converting from one to the other. So to convert from degrees to radians, all you have to do is multiply by the conversion factor, pi over 180. If you're converting from radians to degrees, you multiply by the reciprocal of that, 180 over pi. Again, these two things will be on your formula sheet, so you don't have to memorize them. All right, convert the following degrees to radians. So we're going to take the degrees, put it over 1. We're going to multiply it by the conversion factor, which is pi over 180. Multiply across the top, multiply across the bottom. You're going to get 30 pi over 180. Now you need to reduce the fraction, 30 over 180. Most of you will cancel out the zeros to get 3 over 18. And then you can reduce by factor 3 to get 1/6. Now, a lot of you don't like that because we have a calculator, so why would we do anything by hand? If you want to reduce in your calculator, don't type the pi in, okay? So just do 30 divided by 180. Okay? Hit enter, you'll get a decimal. Press the math button, option 1 for fraction, bless you, and hit enter and you'll get 1/6. So once you do this in the calculator, then you just have to tack the pi back on. So this will be 1 pi over 6 or just pi over 6. Okay, so you're welcome to reduce by hand. You're also welcome to use the calculator. So the next one, negative 150 over 1 times pi over 180. Again, you can use your calculator to assist you in reducing. So negative 150 divided by 180. There's our math fraction button. So we'll get negative 5/6. So it'll be negative 5 pi over 6. It does not matter if you put the negative in the top, out front, or in the bottom. Just need a negative somewhere.
I got negative 200.
That's because you.
Don't type the pi in. You have the answer. You use whatever your answer from last time. Got in there somehow. What does this reduce to get us? 4 ninths? 4 pi ninths, yes. Make sure you have the pi in there for your final answer for radians. Okay? All right, next one, switch gears, convert radians back to degrees. So you basically just take the reciprocal of our conversion factor. You'll notice that the pies are going to divide out because you'll have one in the top and one in the bottom. So those will cancel, if you will. So this time we'll have pi over 2 times 180 over pi. Again, you won't have to memorize which one to use. It'll be on your formula sheet if you just read. And as I said, the pies will always divide out when you're converting back. So we'll get 180 divided by 2, which is 90. That's 90 degrees. Okay, now the next one has a negative out front. I always suggest putting the negative in the numerator. That way you don't lose it and think it's a fraction bar somehow. So let's do negative 5 pi over 7 times 180 over pi. So divide out our pies, get rid of those. And then in our calculator, we can just type in the numerator, negative 5 times 180. We'll get negative 900. And then we'll divide that by 7. And we'll have to round it. So negative 128.57 doesn't tell us what to round to, so negative 128.6, whatever. And that'd be degrees. It's not real statement. Okay, those of you that know the unit circle, you probably know what 2 pi over 3 is. But if not,
Like 180 or something.
because pi thirds is 60.
So 120. Degrees. Not the right answer. Something.
So if you know it, feel free to just do it. If not, divide out your pies, multiply across the top, we'll get 360 divided by 3, which is 120. All right, last of examples has us graphing in radians. Okay? Majority of you are going to want to do this first and then graph it in degrees because you know how to graph in degrees and that's really easy. I will show you in radians really quickly, but you don't have to do it in radians. Now, if you remember, radians go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So pi sixths is 1/6 pi. If the whole thing is like 1 pi, you would just break it into sixths. Okay? So you want to do it that way. Okay, so what I did was I broke it into sixths. 1, 2, 3, 4, 5 sixths. The whole top is 1 pi, so break it into 6 pieces. Pi over 6 would be this one. All right. Now, for those of you that are like, what? Nope, not for me. Take pi over 6 and let's convert it. Remember, to convert 2 degrees, we're going to multiply by 180 over pi. So cancel out your pi's. You'll get 180 divided by 6, which is 30 degrees. You guys know how to graph 30 degrees, right? So you would just draw 30 degrees and be done. Again, 90% of you are going to want to do it that way. Those of you that are more comfortable with radians might want to do it the other way, but most of you won't. Okay, so I'm going to show the rest of them converting. So I think that's what you'll like. Okay?
I think if Mr. Corley showed it this way, it'd be a lot easier.
Yeah.
He just threw it at us.
Since this one's 1 pi, you break it into 6. So if it was fourths, so the next one's negative 3 pi fourths. So first of all, you're going to be going downward, but you'd want to break the bottom half into fourths. So break this in half, half again, and half. So it'd be negative 1 pi fourths, negative 2 pi fourths, which is a half, which is pi halves, and then negative 3 pi fourths. So the answer should be right here. But if you don't like it,
Honestly, if you would have.
okay, if you don't like doing it as radians, then just do it as degrees. So multiply by 180 over pi.
I'm sorry.
So if you prefer to do it this way, we'll just multiply and divide negative 3 times 180 Oops. And then divide by 4. And we'll get negative 135. But in honors pre-calc, you don't have time to convert things to degrees. Like, you don't. In advanced algebra, we do.
We do,
A lot of time.
because we love it.
Okay.
We just love
We're all
math.
So
about
negative 135 will be somewhere over here. Make sure you have your arrow drawing down, since it's a negative. All right, now the next one we get something weird. Okay.
What? I got negative 90.
What? For this?
Oh, not for B.
For C?
Yeah.
No.
Alright,
So we have negative 21 pi fourths. So let's convert that to degrees.
Oh, because I times it by 2, not
180 over pi. Instead of 21, you did 2.
Yeah.
Yeah, we're going to get something really big here.
We did get- I got 930,
Okay, so
945.
negative 21
No.
times 180. And then divide that by 4. Negative 945?
Uh-huh.
Okay, so anything that's over 360 or over negative 360, under negative 360, it goes around multiple times. All right, if it were a positive, we would subtract 360 multiple times until we get there. Since it's a negative, we're actually going to add 360 until we get something that's between 0 and 360, because 360 is one whole resolution. So add 360 once, we'll get negative 585. Add 360 again, we get negative 225. You can graph negative 225. But because we added 360 twice, you're actually going to have a spiral going on.
Oh, gosh.
Okay, so instead of just drawing one arrow to your angle, you're going to have to go around once, around again, and then land on your angle. Now, since it's a negative 225 degrees, let's use our negative reference angles. So start at 0, negative 90, negative 180, and negative 270. So negative 225 is going to be somewhere over here in quadrant 2, right? So again, I'm going to go draw my arrow, go inside, go around once, twice, and end over there.
do that again, please.
So the 360 I went around once, then I went around a whole second time because I have 360 and 360, and then I ended on 225. So it should have 2 loops, 2 full loops and then a partial. All right, try your closure problems, and then your homework are all worksheets in the trig unit, so no book required.
Oh, that's fantastic.
Okay, now please be aware, a lot of them are fronts only. So tonight, the next page in your packet is your homework. You're only doing the front of it. The back of it is tomorrow night's homework. You don't know how to do it yet, so make sure. But we'll get 3 of you to the board to graph these closure problems.
We were
We're still playing the piano 12th period.